All right, let's do some trig equations in radians. We've got to make sure we understand what a radian is. Know that 1 radian is approximately 57.3 degrees. Now, I'm not going to put the 0.3s in this little chart, but if I wanted to know where 2 radians was, if I add 57 to that, that's about 115. If I add 57.3, approximately there, and I could keep adding the 57.3 and I would get these values. Now I could certainly mark those in degrees because you would certainly have an idea of where those were, but I just want to also make sure you understand and have the relationship between, like, we've been doing radians, pi over 2 and pi and 2 pi. If I ask you what pi was as a decimal, you would say, well, I already know that. That's 3.14. What you're saying is 3.14 radians. If I ask you what 2 pi was, well, that would be 6.28. So there's approximately 6.28 radians around a full circle. And if I wanted to divide the circle into 6, into those radians and put the radians on there, well, I mean, 1, I'll try to do this evenly. I'm not the best drawer there, but if I could split this into equal things, I mean, about there, I don't know. I mean, that's somewhat close, I guess. Or at least I try to be. Maybe the 2 is a little there, but whatever. You get the idea of those. That's approximately 1 radian, 2 radians, 3, 4, 5, and 6. Now, I don't necessarily memorize the radians, but what I do know is I do the quadrants. Because if I say determine the quadrant for each, this is what I do. I'm like, okay, I certainly have the 0 and the 3.14. I would know that pi over 2, if you did that on the calculator, is 1.57. And then if I wanted to do 3 pi over 2, which is down there, well, if I just add these 2 together, that's 4.71. So if I know that, I can tell you any quadrant. Because if I said determine the quadrant for 5 radians, well, 5 is between 4.71 and 6. So that's going to be in quadrant 4. And if I said 0.487, well, that's clearly in quadrant 1. 2.5 is in quadrant 2. Now, negative 3.5, be careful. Let's think about that. If I went 3.5 radians negatively, though, that means I'm going this way. That would be negative 3.14 radians. I'd have to go a smidge more. So that would also put me in quadrant 2. So knowing where those are is a big deal. Again, with the purposes of our homework, it's really smart to know these values, the 1.57, 3.14, 4.71, and 6.28. And of course, 0, not going anywhere. All right, so let's do these values. Now, the good news is what I'm doing, you are going to see that it's very similar to what we did yesterday. But I have to do a couple things on my calculator. Now, I'm going to pull up a calculator. Mine doesn't look exactly like yours does, but it's going to do the trick, okay? But I will pull up a calculator in just a second before I set this one up. Here's the couple things that we have to remember. First of all, I need to make sure that I isolate my trig function. So that's going to be kind of my first step. I'm going to get down to cosine of theta is negative 1/5. I'm going to get my trig function all by himself. So what I need to understand is that what I'm going to type in and how we're going to do this, you're going to have to kind of just trust me, okay, is that my theta, my reference angle, I'm going to type in inverse cosine. When you type it in to do the formulas that we talked about earlier, you're always going to type in a positive number here. Now, what I figure out with this negative is I'm like, all right, if cosine is negative, I'm going to have answers in quadrants 2 and 3. That's what I figure out with the negative, and that's what I figure out first. Now, how do I get my actual answers? Well, I am going to get on the calculator, and here's where I'm going to call up my calculator here. Let me take a minute, 1 second. There we go. Let's hit my mode button. Yours looks a little different, but what I'm saying is the same. My mode button, I would need to be in radian, which I am. And now I'm ready to go. All right. I am going to hit inverse cosine of 1/5. That's going to give me, let's see, second cosine of 1/5. So 1 divided by 5. And the calculator gives me 1.369. Now, I'm going to be honest. I don't like to hit a lot of buttons. Okay? So this is something I like to do, and this is also helps you, calculus-wise in storing. I don't want to have to hit 1.369 so many times. So very quickly, I like to store that into A, okay, for alpha. How you do that is you hit the STO button that's above your on, and then alpha A, and I hit enter, and that is now stored into alpha. Now, how do I get my actual answers? You told me that my answers were in quadrants 2 and 3. Do you remember, and I'm going to erase this chart when I get to number 6 because I need the space, but do you remember how in quadrant 1, your theta was alpha? In quadrant 2, it's pi minus alpha. In quadrant 3, it's pi plus alpha. And 2 pi minus alpha. Same exact formulas as yesterday. We just said 180 degrees minus alpha or 360 minus alpha. Well, in radians, it looks like that. So since I know my answers are in quadrants 2 and 3, I am going to do my two actual answers are theta equals pi minus the alpha and pi plus the alpha. Now to do that on the calculator very quickly, I've already stored that into A. So I usually do it in one fell swoop. Notice that there's a pi button over here kind of next to the exponent. So I'm going to put pi plus alpha. And that's one answer. I happen to write that one second. So 4.511. And I'm going to do pi minus alpha. And that gives me 1.773. These are the two answers I would put on the answer blank. Okay. So that storing is nice just because I don't want to have to type in 1.369. Again, I'm kind of a lazy person. I like hitting 2 buttons rather than 4, I guess, or 5. So I like that store. I like that. All right, let's look at number 6. I am doing those same steps throughout these problems. First of all, I have to isolate the trig function. Now let me think about that. Let me isolate the trig function. I would have negative cosecant of theta. Be careful, I'd bring that 7 over, or that 3 over, so that would be equals positive 4. So cosecant, are you with me? I'll just erase it here. Are you with me that cosecant would be negative 4? All right. If you have an inverse trig function, the only buttons I have are inverse sine, cosine, and tangent. So if the cosecant of something is negative 4, then I know the sine of that something is negative 1/4. Now that negative is important. This is where I figure out what quadrants I'm in. So what quadrants I'm in, if the sign is negative, that's here and here. So I know that, and I want you to write what I'm writing on my paper, I want to be on your paper, because I can give you some partial credit if I see kind of how you're getting your numbers. If I don't see how you're getting your numbers, now I don't know what you did. So you're going to write down, how do I get my reference angle? It's always inverse of the positive value. I use the negative to know that I'm in quadrants 3 and 4. But I do inverse sine of 1/4. Let's get that on my calculator. So let's clear that. Second sine. Now I could type in 1/4 since I know that decimal. I'll just type it in like that. And I get 0.253. And then I go back to the chart with my thetas. I know in quadrant 3, it is pi plus alpha. And in quadrant 4, it is 2 pi minus alpha. And I'm going to get my 2 answers. So again, I like the store thing. Store into A. And I'm going to type in pi plus A. And I'm going to type in 2 pi minus A. And there are the 2 answers that I get. 3.39, I guess 4. And then 6.031. Now, the reason why I kind of wrote those things up top is because, y'all, if you tell me my answer is in quadrant 2, and then you tell me one of the answers is, say, 2.615 or something, or I just made that up. If you're in quadrants 3 and 4, your answer should be between 3.14 and 4.7, and then 4.7 to 6.28. There's no way that's going to be a correct answer. That's why I say I like to have those memorized, those quadrantals, because it kind of helps me check my work. All right. Why don't you try number 7 on your own? So I think it'd be smart to stop the video and see if you can get number 7 all the way through. And then turn me back on. All right, here we go. First step, isolate the trig function. Now be careful. Write as many steps as you need to do that. Bring the 1 over. So I'd have the secant and I'd have 3/5. I could write it that way. 3/5 secant is equal to 1. So if I switch that, the secant of theta would be 5/3, which means the cosine of theta is going to be 3/5. In that moment, I know that cosine is positive. That means x's are positive. My answers are going to be in quadrants 1 and 4. So my alpha is inverse cosine of 3/5. Let me get that on the calculator. Second cosine of 3/5. And my reference angle is 0.927. Actually, 928. I'll be better at rounding there. Well, golly, I was looking at the wrong number. It is 7. Outthought myself there. All right, 0.927. And then what are my 2 angles? Well, the good thing in quadrant 1, one of that 0.927 is the answer in quadrant 1. Remembering in quadrant 4, it is 2 pi minus, and I forgot to store. I'll just do second answer. That's another way. If I'm just doing it one time. And my second answer is 5.356. These are my 2 values for theta. All right, last one is non-calculator. Find all the angles that satisfy the equation. I'm just in radians. So do not use a calculator. No problemo. I'm going to isolate the trig function. I get sine squared is equal to 1/2. Remember, when I take it down to Sine, I have to remember the plus and minus square root of 1/2. Now, when you get to there, you might be thinking, oh gosh, I don't know that. Well, if it's on a non-calculator part, you do know, because it has to be one of the special angles. I just have to make sure. I'm like, well, the square root of 1/2 is really the square root of 1 over the square root of 2. Now, the square root of 1, of course, is just 1. So plus or minus 1 over square root of 2, which is square root of 2 over 2. And oh, goodness, you know that that's all of the pi over 4s. And so my 4 answers are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. No calculator needed. All right, so there you go. Have a good one.